you'd think it would be.
Oh, really?
Yeah.
How hot are we talking?
Well, the surface of the sun is already like 5,500 degrees Celsius,
Right.
which is hot enough to melt pretty much anything on Earth.
Yeah.
But then you get to the corona,
Mm-hmm.
the outer layer of the sun's atmosphere.
Right.
It can reach millions of degrees Celsius.
Millions.
Yeah,
Wow, that's like hundreds of times hotter.
I know. It's mind-blowing.
It really is. And for scientists, it's been this long-standing puzzle. Why is the corona so much hotter than the sun's surface? Shouldn't it be the other way around?
Yeah, you'd think as you move away from the sun's core, it would get cooler.
Exactly. But the corona flips that idea on its head.
Yeah.
So how do we explain this? Well, there are two main theories that scientists are investigating: magnetic reconnection and waves in the sun's magnetic field.
Okay, let's break those down. What is this magnetic reconnection thing all about? I mean, I know magnets have these invisible fields, but I never really thought of them as being so active.
Well, think of it like this. Imagine the sun's magnetic field lines as this giant tangled mess, kind of like a bowl of spaghetti. Now picture those strands suddenly snapping and then reconnecting. That's magnetic reconnection. When this happens, it releases a ton of energy, and a lot of that energy gets released as heat.
That's pretty wild. But how do scientists actually see this happening? It's not like they can just look at the sun with their naked eye and see these magnetic lines snapping.
Right, of course not. Scientists have these special telescopes, both on the ground and in space, that can detect the different kinds of energy that are given off during these reconnection events.
Oh, I see. So they're sort of like listening for these telltale signs of magnetic reconnection.
Exactly. And then there's the other theory about waves. Think of those same magnetic field lines as, well, like strings on a guitar or something.
Okay, I'm with you.
So, you know how waves can travel along those strings? Well, similar waves can travel along the sun's magnetic field lines, carrying energy from the sun's interior out to the corona. And as these waves crash and dissipate, they deposit their energy, and that's what heats up the corona.
Wow, it's like the sun is playing its own kind of music
Yeah.
with these waves carrying the tune of heat all the way out to the corona.
That's a great way to put it.
So we've got these snapping magnetic lines and these energy surfing waves, both potentially pumping up the heat in the corona. It sounds like we're still piecing together the full picture.
Absolutely. There's still a lot of research to be done to really nail down how these mechanisms work and how they interact to create this superheated corona.
This is amazing. So just to recap for our listener, we have the sun's surface, which is already incredibly hot at 5,500 degrees Celsius, and then boom, the corona, millions of degrees hotter. And scientists are exploring these two main theories, magnetic reconnection and waves in the sun's magnetic field, to try and understand why this is happening.
And you know what's really cool? When you think about it, this is just one example of how much we still don't know about our own star. It's this massive, powerful object that literally drives life on Earth, and yet we're still figuring out its basic workings.
It's a humbling reminder that we're still just scratching the surface when it comes to understanding the universe.
Definitely.
Well, listener, I hope this deep dive into the sun's sizzling corona has given you something to think about. And remember, keep exploring, keep asking questions,